In previous class, we have discussed some topics like what is motion and rest, what are the physical quantities and types of physical quantities like scalar quantities and vector quantities, and also what is distance and displacement and speed and velocity and average speed and average velocity and acceleration. Now, today we gonna study equation of motion. These equations describe motion of bodies. So, there are three equations for motion of a moving body. These equations are: first one is v, final velocity here, v equal to u plus at. Second one is s equal to ut plus half at square. Third equation is v square minus u square is 2as, or you can write as v square is equal to u square plus 2as. So there are many methods that you can prove this equation, but today we gonna prove this equation by algebraic method. Here we gonna use algebra for proving this equation. So first one is the first equation of motion. First equation of motion. So first equation of motion is v equal to u plus at. As we know that here v is the final velocity. Here it is a small v. It is the final velocity of the body. U is representing the initial velocity of that body. A is the acceleration and t is the time. So now let's suppose we are considering a body having initial velocity u and final velocity is v, and it has a uniform acceleration a. So the uniform acceleration is a, so that after time t its final velocity became v due to that uniform acceleration. As we know that acceleration acceleration it's also denoted as small letter a, is change in velocity, change in velocity upon time. So what is change in velocity? Change in velocity is just final velocity minus initial velocity upon time taken, time. So it is a equal to final velocity v, initial velocity is u upon t. Now we can write as at equal to v minus ut. Now this will we can write as v is equal to u plus at. We just moved t from right hand side to left hand side, then we just move the initial velocity, that is u, from right hand side to left hand side. So this equation becomes v equal to u plus at. Here it is not, that's not the t sign, it is just plus sign. So it is v equal to u plus at. And this equation gives us the velocity of that body in time t. So this equation just give that velocity acquired by a body in time t. Now we're gonna prove the second equation of motion. Second equation of motion. So second equation of motion is displacement, that is s is u t plus half at square. So here s is what? S is displacement, u is initial velocity, t is the time, a is the acceleration, now let's suppose a body has an initial velocity u and it has also a acceleration, uniform acceleration a for time t, so that its velocity became v. So a body is, let's say a body has a initial velocity u and a uniform acceleration a, means the body is accelerating, and after time t its velocity becomes v, that is the final velocity. And let's say in this whole time it covered some distance s. So as we know that average velocity average velocity is arithmetic sum of initial velocity and final velocity, that is u plus v upon 2. So average velocity is the arithmetic mean, sorry, not sum, arithmetic mean of initial and final velocity. So let's take an example. Suppose that here is a ball, it has a uniform velocity u and it's accelerating, uniformly accelerating. So its acceleration is a, moving in this direction, and after t its velocity becomes v. Now it covered some displacement or distance as in time t. So the average velocity will be u initial velocity plus final velocity upon 2. We have discussed that the average velocity is total distance upon total time, and also this average velocity is initial velocity plus final velocity upon 2. Now we know that average velocity is also total displacement or distance, total displacement or distance upon total time taken. Sometime I'm using the word distance, but it's mean the displacement. Here, whenever we say velocity, we deals with displacement. And sometime in practical, we use the term distance because displacement is just a distance with a direction, because that is a vector quantity and distance is a scalar quantity. So the magnitude of displacement is distance. Now the average velocity here, total distance upon total time. For this particular case, the total distance is s and total time is t. So this will be s upon t. Now here is the average velocity. Now we can say that distance traveled by that body or the ball is equal to the average velocity into time. We just moved t from to left hand side from the right hand side. So this will be that much. Now the average velocity also equal to u plus v upon 2. So we have to just put this value, this expression in here. So we have to just put this expression on here. So this s will become, average velocity is what? Average velocity is u plus t. We can write as u plus v upon 2. So this will be u plus v upon 2 into t. Now from first equation of motion, we know that the final velocity of our object is equal to initial velocity plus acceleration, product of acceleration and time. Product means multiplication. So this will become as u plus, we have to put the value of v here. We have to put the value of v on here. So v is what? V is just u plus at upon 2 into t. Now u plus u, that will be 2u plus at upon 2 into t, and this will becomes 2ut plus at square. So we just multiplied this term with t. So t into 2u will be 2ut plus t into at is at square upon this 2. Now this s will be here. Now we can take 2 common, so here it will be like 2 ut plus half at square upon 2. We just took 2 as common, so here 2, and there is no 2 in this term, so it will be 1 upon 2 at square, and this 2 and this 2 will cancel out, and we get ut plus half at square, and this is our second equation of motion. And this equation gives the displacement covered by a body in time t. So this equation gives displacement or distance meant or distance covered by a body in time t. Now the third equation of motion. Third equation of motion, and it is v square equal to u square plus 2as. From second equation of motion, s is equal to ut plus half at square, and from first equation of motion we have v equal to u plus at, and we can also write this expression, this equation, as v minus u equal to at. We just moved u to this side from this side, means we moved this u to left hand side from right hand side. Now this t will be v minus u upon a. We just moved a from this side to this side. Here it is, the operator is multiplication, and we if we moved from this side to this side, this operator become division. We can we can also get this t from this equation. A is ut, sorry, a is v minus u upon t. From acceleration, we know that acceleration is change in velocity upon time, and from here we can write this expression, as t equal to v minus u upon a. We just interchange the position of a and t, so we get t equal to v minus u upon a. Now just we have to put this value of t, we have to put this value of t from here to here. So as the displacement from second equation of motion, s will equal to u t, so the value of t is that much, so it will be v minus u upon a, and plus a plus half at square, so the value of t is v minus u upon a square. Now this s will equal to here v into v into u vu, and u into u square, so it will be u v minus u square upon a plus a, this is like a minus b whole square, so it will be a square plus b square minus 2ab upon a square, and this square will cancel out with this a. Now this s equal to uv minus u square upon a plus half v square plus u square minus 2a 2 sorry v square plus u square minus 2vu upon a. And we have, so this will become a plus 2 2a, so it will be 2a, and here it will be 2 uv minus u square plus here 2a, so it will be v square plus u square minus 2vu. Now s will be 2 uv minus 2u square plus u plus v square plus u square minus 2vu upon 2a. Now we can cancel out some term like 2uv and minus 2uv. This term will cancel out, and next one minus 2u square plus u square, this will be minus u square. Okay, here minus 2u square plus u square, so here minus 2u square plus u square will be minus u square, so s will be minus u square plus v square upon 2a, and this will v square minus u square upon 2a, and this will be square minus u square equal to a s. We just moved 2a to this side, and u square will be equal to u square plus 2as, and this is the third equation of motion. And it gives the velocity of a body in traveling a distance s. So it gives the of velocity acquired by a body in a traveling a distance or displacement, a distance s.